Hello again, welcome to another walkthrough of the same CTF road CTF challenge, and this is a pretty easy challenge called tunnel. Basically it's a DNS exfil challenge where you're given a pickup file containing DNS data or DNS records, DNS streams, of which shows somebody trying to exfiltrate some data via a DNS query, and it is pretty straightforward, pretty easy. This is gonna take 3 minutes to wait. Oh, to make it more interesting, we will use awesome. Now here's the plan. I don't know how this is gonna work. Yeah, I don't want to record this again, but let's do this. Here's the plan. Let's try and solve this in two different ways. The first way being using Wireshark, which is the easy route, and using Scapy. Oh, demo gods, be with me. Okay, so for those who don't know, Python is an interpreted language, a scripting language actually, that's very useful in your journey as a cybersecurity analyst. And Scapy, now that's the scalpel for packets. It is a very interesting module in Python that assists us to manipulate packets just like how Wireshark does. But unlike Wireshark, which you don't really have, or kind of shows these packets in fields, yeah, Scapy builds packets as Python objects. Well, what this means is you can actually dissect and manipulate these particular packets live, unlike in Wireshark. Well, you can do a lot in Wireshark. You have a lot of power in Wireshark, but the scripting power that Scapy gives, from how you can manipulate each stream, each layer, etc., it is so powerful. We are going to see it. Okay, before that, let's try and go through this walkthrough without Scapy. Let's go through it with Wireshark. Now, what is this challenge about? As I said, it's a DNS exfil challenge called TUNN3L, and here's the description from the module. What use information do you get from your analysis? Now, this was pretty straightforward, especially the questions were like a guideline that was too much of a guideline, if you know what I mean. Anyway, okay, so it says, what is the IP? Hold on a second. You first need to download the particular file. It's a zip file that contains the DNS exfil pickup. I have it already, so I'll just start up Wireshark, and here we have it. It is the DNS exfil pickup. Open it up, and we only see two streams. One DNS record, it's a query, and then a response that looks like an error. Okay, cool. So let's begin answering these questions. The first question is, what is the IP address of the machine exfiltrating data? Now, if you've been around for a bit, or if you've played around with IP addresses and all that, you'd come to know that 8.8.8.8 is the DNS server for Google. So basically it cannot be the attacker's machine, right? It definitely is a DNS server that the attacker is trying to query, and while doing this query, it's kind of sending data over. And here you see the source of that particular query is 192.168.1.74, which is our answer for the machine that is exfiltrating data. Il perfecto. Now, question 2. What is the full domain name used by the attacker for that exfiltration? And here's the example. It's attacker.com, so it just needs the domain name itself minus the subdomain name, which looks weird. Oh, Okay, anyway, so the domain name is crazycat.com. The third question, what type of DNS record is primarily being used for the data? For that, we'll select the first, go down here, we say domain name query, and then queries, and then right here we say it's type A, which is the A record. Type A. That one is used to query for IP addresses. So it's for resolution from a domain name to an IP address. Yeah, okay, question 4. What encoding method was used for the exfiltrated data within the DNS query? Now, if you've seen this a lot, you'd notice this looks a lot like base64 encoded string. So the syntax here, my assumption is the first part, which is a 0, it looks like an index, a number, and an integer that maybe it's used to identify this particular data being exfiltrated. It is separated by an hyphen, and then the next part is the data being exfiltrated, which is base64 encoded. So answer, base64 encoding. Now if you take that, separate or remove the prefix, the first part 0 hyphen, and then you decode it, you'll find the flag for the last part. Cool. Yeah, we are done with the easy part, the very easy part. Now let us do the other part that I don't know how it will go. So we're gonna use Scapy. And what is Scapy? You can just Google Scapy. Here it is. So the last time I used Scapy, I think, was in 2023 or 2022 when I was creating a tool, a pickup CTF tool that I wanted to use it to just automatically solve such CTF challenges from extracting what do we call it, tickets, or let's say TGTs from the packet, or extracting credentials and TLM hashes, extracting DNS data, etc. from the packet, even TCP, raw TCP connection, passing through them and checking if it's data being exfiltrated or something that can be extracted. That was the last time. I think Scapy is powerful. It is a very interesting tool. Yeah, so we're gonna see that. So first, let me open up a terminal. Perfect. Now that is that. Let me increase a little. Perfect. So let's move into the path where we have the DNS exfil file. So we have it here. So I'll just copy it. So because I don't have Scapy installed, I'll install it real quick. So to install Scapy, you just use pip3 install Scapy, and I don't want to use VNV or a virtual environment. So what I'll do is I'll just tell Python or pip to just break system packages, break system packages. Okay, perfect, and that is good. So it seems I had uninstalled it earlier because it looked like it was cached. Okay, so when I run Scapy, so there are different ways of using Scapy. So one of them is the way I'm using it. You can use Scapy just the way you use Python. Just run the way you run Python, and then you get like a prompt, and you can actually execute Python statements there. It's the same way you can run Scapy, or you can actually import Scapy inside your own Python scripts. Now for these, we're just gonna stick to using it in the Scapy interpreter. Maybe in the next videos, maybe not immediate videos, but any day we'd meet a pickup file that is more interesting than this, we can actually script and see how interesting that is. Now, to read a packet inside Scapy, so first we'll create a variable packet, and then we'll use rd pickup to actually read the packet. So then let's exfil, and then we've read it. As I said, Scapy is object based, right? So unlike Wireshark, as I said, where you actually you actually reading decoded fields, Scapy works differently. Yeah, it is each packet, or the packets itself, are Python objects, so meaning you can actually play around with them, play around with the layers, play around, use interesting functions to actually mutate, etc. So for example, if I want to check the summary of this packet, let me first do this, and then I'll just say packet dot summary. As you see, I can now view the summary of this packet. We only have two streams, and the first one is the query and the second is the response. As I said previously when we were looking at it on the Wireshark, the next response looked like an error, and indeed it's a name error, so meaning resolving, or the resolution of the particular domain failed, so it returned a name error. Now, as much as we can just see the summary, you see each layer looks like it's independent, or each stream is independent, and actually it's true. We can access each stream using indexing in Scapy. So for example, I can do packet and then index 0 to select the first one, which is the query, and then index 1 to select the second one, which is the response, or the DNS response. Yeah, DNS query response. Okay, perfect. Now, looking at it this way, it looks a little bit raw, and reading it can be a teeny bit tough, but still readable. But there's a better way. We can actually look at it in a more layered and sequential form, more like it's just different in printing, like using pp print. Just do dot show, use the dot show method to just show the layers in a more layered manner. Yeah, so as you see, each layer is shown from the Ethernet layer down to the DNS layer itself, from Ethernet, IP, UDP, and then DNS. As you see, because Python, this is object based, the packets are object based, each and every layer is accessible. So I will just turn this up there, and then just use, let me just do packet and then 0. Now for example, if I want to only get I don't want the Ethernet layer, but I want to get from the IP layer to the end, all I have to do is actually just select the IP layer, and I get the IP layer. So the IP layer comes and ends at okay. The reason why this happens that way is because I've selected the IP layer in a list of packets, so I need to select one packet. So let's say packet is equals to packet, and then let's say I just want packet 0. Now if I do packet like that, and then I select the IP, now you see it's better. I even get the records here. So here we have it. So you see, I no longer get the first part, the Ethernet layer. I only get from the IP layer to the end. I can continue doing this. I can only get the UDP layer, so that removes the IP layer, not removes, but doesn't show us the IP layer, or retrieves only the UDP layer. And then I can also go further and just say I want the DNS layer. I can go further, and then I just say I want the DNS query. Oh, sorry, this is not defined because I think I have messed up the spelling. DNSQR, not DSNQR. Okay, fat thumbs. Perfect. Now we've seen it is object oriented, and we can actually access layers just like the way you play around with the objects in Python. Now, notice how the packet DNS itself gives us results, and we see like each field there is equal to something, or maybe as I would say a reference, meaning we can actually access or like access individual elements inside this particular DNS record. So for example, if I want to access maybe the query name, so because allow me to just clear again, so I'll just do packet DNS, right? So let's say I just want this query name, right? So what I'll do is I'll just do DNS, and then I'll go ahead and say this is qd dot q query data, not gd but query data, and then this looks like it's in a list, so I just want the first element, which we only have one element, as you see. So I'll just say 0, and yeah, we get it. We get that. Yeah, and we can also use it simply. Instead of using qd, we can just select the DNS QR and just get the queue name or the values we want from it. So I can go ahead and do more and just do dot queue name. Perfect. Now let's try and answer the questions. Now that we've seen or we've understood how to access each layer in Scapy, let us see how we can actually answer all the questions. So question 1, what is the IP address of the machine exfiltrating data? Now that is the IP layer, correct? So all we need to do, let me just go there, Control L. Why did I do that? I'll just do IP. Perfect. Now what we're interested in is the source, so I'll just do that and then capture the source, and that is our IP address. Perfect. Next question is, what is the full domain name used by the attacker for data exfiltration? Now here's where we do some Python foo. Okay, so we do know that is the query name. We select it from the DNS, the query data at index 0, and then the query name. This is the domain, but this is not what the question asks for. It only needs the format attacker.com without the subdomain. So we need to strip this part. Now let's do some Python foo. So I'll just do dot, and then I will say split, right? Now because this is bytes are denoted by this b right in front of the string, so I'll have to split it using a byte, split it from that. Now when I do that, we have a list, right? So what we need is this. Well, we need to remove this, but we're going to remove it in just a second. So what we'll do is just say select from 1, because we start indexing from 0, 1, 2. So select from 1 to 2. 1, no, not 1 to 2, but 1 to the end, not 1 to 2. But if you don't want the last one, so this is 0, 1, 2, 3. So 1 to 3. So it's 1 to 2, like 1 to 3 minus the last entry. Okay, so it doesn't include the last value. So 1 to 3 doesn't include the third element on the list. So we have that. So all we need to do now is just join this. So we just use join dot join. So we are joining these two elements in the list with the period. Okay, did not say dot join, I just said dot. I forgot to add this. Thank you. So we need to do that. So as you remembered, I said bytes are denoted by the B, but here I was trying to perform an operation of bytes and ASCII. So it says byte and string. It said expected string instance bytes found. So it could not actually work. So I needed to use bytes to actually join those two. And here we go. We have the domain. Okay, the next one is what type of DNS record is primarily being used for the data exfiltration. Now we need to get the DNS query. We have the question, the queue name, and then the queue type. So I'll just do it again and then just say let me put this here and then DNS QR. Now as you see, we have the queue name and then the queue type. Now here's the interesting thing. If we do dot queue type, it will actually return an integer. So the reason being because Python types do not include such. This is just a representation of A in this particular string, or the way we're looking at it is already been converted to A, but when you're accessing it and want to utilize it, we will use it as a type that Python understands, and that right here is an integer. So this one equates to an A record. So if you just Google and check A type equates to 1. Let's add DNS so that it has DNS A record. Yeah, A is 1. This is A28 NS2 CNAME5. So this is what we have here. So this is an A type or an A record. That is the answer to this question. The next question is what encoding method was used for the exfiltrated data within the DNS query? Now this already we know it's base64, so we need to select it. So we'll select QNAME, but we only need the first part, so we'll just do dot split split with bytes of dot, and then this time we're just selecting the first index, so we only have that. But still we need just this part, because as I mentioned, this looks like an index separated by this. So we will split again, dot split, and then with a dash, and then this time we will select the second index, and here we go. Now this is a base64 string, so that was the answer for this. Now the next question is, after extracting and reassembling the fragmented data from the DNS query, what is the complete decoded string in the final flag? So we need to decode this string. So using Python, we'll say from base64 import base64 decode, and then we will set this to a variable. I'll just put it, no, oh god, I don't know why it's breaking like that, but it's okay. So I'll just set this to a variable and say data is equals to, right, and then I'll say base64 decode, and then say data. What happened? Oh, not decode, but decode data, and there we go. We have our flag. TUNN3L DNS like a Pro. Okay, this one is a Pro plus plus because we used Scapy. Anyway, thank you for following along till the end. This was an easy challenge. I just felt like I could show you more using this particular challenge. In any other pickup CTF or pickup challenge, I might continue showing you the usage of Scapy and just scripting your way through CTF challenges and creating your tools that will help you solve them faster. Yeah, thank you, and did like and subscribe. Anyway, cheers, thanks, and have a nice one, guys.